Hey everyone, today I'm going to be showing you how you can make this really cool grid scan effect in Blender pretty easily actually. I used this recently in one of my renders where it was actually more of an asset in my render where I rendered out this video separately and used it as an image plane on my device, whatever. That's not important. I was looking for a way to kind of do this fun parametric animated grid scan effect on the surface as you can see here, and I was trying to figure out a way to do it, and I couldn't really find any good tutorials online, uh, at least for the way that I was planning to do it in this kind of non-destructive way. And so I found this technique that I think is really easy to replicate and honestly really fun. You can build on it as much as you'd like. So I'll show you how to make it here. From this, it seems a little complicated, but I promise you'll see it's actually really simple. And the fun thing about this is that everything is modifiable, right? So you can change the grid thickness, for example, the lines. There's also some crosses that slowly take shape throughout the animation, for example. So this is a really fun kind of dynamic uh, lighting solution, I guess you could say, that I found for renders, which is really fun. So how do we make this? Of course, we're going to start with a blank file. Delete everything, Shift A, send in a new plane. So we're going to first need also a shader editor tab. Set this to cycles, which we'll use later. And this is pretty easy, right? We'll see that it's based off of a pretty simple coordinate trick using the UV coordinates of this plane here. We actually set it to the shaded view. We can see pretty quickly. So we're going to use Control-T first to get the texture coordinates of this plane. And if we plug that in right away, if it would like to work, we plug this straight into the base color, you can see the texture coordinates, right? So here we have, let's say, these are the y values going from 0 to 1 and the x values going from 0 to 1, for example. And so we get this distribution of points, I guess you could say, on this plane. How do we take advantage of that? Pretty simply, if we use the separate x, y, and z node, right, we can directly separate these x values, which we saw, going from 0 to 1. The problem here is that, first of all, if we want to rotate our effect, that won't work from this position because it's starting at the edge and not the center. So we want to send in first a vector math node. We're going to set that to subtract and get rid of 0.5 in all directions. So here it centers actually our UV in the middle, right? So if I get rid of the separate x, y, z, you can see that now our UV coordinates are centered on the middle of the plane. This is going to help us for the rest, right? This is pretty general in most textures. I'm sure most people are aware of this, but in case you're not, that's why we do that. So now that we've separated this x coordinate, right, we have this line that's forming, but we want the sort of mirror image on the other side here. We want to have white or black on both sides so that we have a clear line. How are we going to do that? First, we're going to use a math node and this fun little thing called the ping pong node. You can see we get this line. So we already have half the problem solved. We have one of the lines. We just don't have a clear, sharp line. So if we also use another math node and we set it to, let's see, less than, we change this threshold, you can see we can kind of control the thickness of this line, right? This is in the x direction. You can also do it for the y direction. So our goal here is going to be to kind of combine both these x and y coordinates so that we can get a grid effect, right? Well, this is only one line. A grid has a lot of lines. How do we do that? We're going to send in a vector math node again and just change this simply to scale. And as you can see, it's just going to repeat our UV coordinates and we get a series of lines. So now we already have basically half of our grid solved. And using this grid block, we're going to repeat this multiple times. So we want also the same thing for the y coordinates. So let's just copy and paste that, send the y coordinates in, and we kind of see what happens now. Well, we get the same effect, but in the y direction. Or rather, it follows the x direction, but using the y coordinates. What we want to do now is combine both of these so we get this grid pattern with both the x and y lines. So we're going to use another math node and set that to minimum, right? So now if we set both these inputs in and we visualize that, what does it give us? It doesn't give us what we want. So why is that? Well, it's because it's giving us the minimum value, right? So minimum is going to be 0 because it's black. And if you look at the maximum, well, we get all the lines, right? So it's going to combine, it's sort of like a math or a mix RGB node here where we're adding all the values. So we want to only keep the maximum, which is 1, which is these white lines. Whereas if we use the minimum, we will always only get these intersections because it's where they're overlapping, of course. So we'll keep this to maximum for now because we want the grid, but we'll use this effect later for example, the grid suppression and also for the crosses. But if we set this to maximum, we basically have our whole setup. So let's set up a frame, first of all. Put all this in the frame because we're going to use this here multiple times. This is basically the whole node setup. You'll see we copy paste this a few times and it gives us the whole entire setup. We also want to kind of set this into its own group. It'll be easier for controlling all of the commands later. But also now something that's fun is we can rotate it by using a vector rotate node. And so now earlier, as I showed you, rotating it from the mapping node isn't really the effect that I want. Maybe that's what you like, but if we use here this vector rotate after the subtract node, we get something that's more accurate because it's using, I'd say, the local coordinates rather than the general or global UV coordinates for this plane. Let's set that to 0 for now, and we'll also input the scale, right, because we want to be able to control that from outside the node group. We also want to change the, for example, the threshold value. So let's hit N and open up the panel for the node group, and we can change the input group here value. Let's just say grid thickness for now. That should be, oh, sorry, that's the scale actually. I just saw it's this one. That's our grid thickness value. So we're going to use this grid thickness value with, I'd say, a minimum bounds of 0 to, let's just say 10, right? No big deal. I don't think we'll go all the way up to 10. We'll use shift right click to create this node separation, a little branch here, so that they both get the same value, and we keep this kind of constant thickness along the lines. Let's see what happens now. We change our grid thickness value. Well, there you go. Get this thickening or thin grid. And we kind of get the effect that we were seeing before with these squares, but reversed. So if we keep this low around 0.02, we get this grid effect that we're looking for. And if you want to stop here, well, you can stop here. You basically have everything you need. You can skip later on into the video where I show how you can apply this to a light, which is more useful. And here you can basically control everything. So you can make it turn, the scale, the thickness, and this is already a pretty fun asset that you can use, right? For now, I'm using this plane instead of light because it's easier to visualize. But I think we can take this a step further. So how do we get that kind of grid suppression effect, right, where these lines here disappear? I think that's a fun dynamic way to play with this lighting. So first of all, let's rename this frame. And to answer my own question, how can we do that? Well, we're basically just going to copy paste this value, right? But instead of recreating the grid like we did here, we're going to actually use minimum so we get the square effect that I showed earlier. So first let's connect the x value to the first one and the y value down to the bottom one. And let's create a new, let's create a new value here for the input. So again, let's open that up and we'll set the minimum value to 0. And I know that the maximum value will be 1, right? Because we want to go only to the bounds of these lines. So basically 0 to 1 for each segment. Let's call this grid suppression. I'll just put grid sub for now. And now they're both sharing the same value once again. So what happens if we visualize this now, right? Well, we get what we were saying before. I think I need to change this value. We get these squares. So that's actually what we want, because if we overlay this over this effect, for example, well, we can kind of block out these sections. So if we hit invert, for example, and then we input this, we can see how this black section is going to be, let's just say, superposed over these junctions, and it's slowly going to grow and make these lines disappear. Now, once again, we just have to kind of combine these two. So we'll use minimum because we want to keep, oops, sorry, let's put in a math node, because we want to keep the black regions, right? We want to kind of overlap these black regions. So we'll input the top value, bottom value, and now you can see we kind of delete the center of these nodes, right? So now if we leave, we can see that by increasing the grid suppression value from 0, it's full grid, to 1, we have no more grid. So now we have the grid suppression effect. You can animate this if you'd like, slowly make it disappear. Also, another fun thing you might be able to do is if you separate your x, y, and z coordinates separately from these values, you can change the position as to where these start. So if you want, you can make the square start, for example, in the center of the line rather than at the junctions. That's up to your discretion. I thought it looked cooler from the center, so I'll stick with that for now. Now, how did I make the crosses or the sort of plus signs here that form in the junctions? Well, it's once again the same node group, but repeated again. So kind of copy also the junction. That'll help for in a second. So now we have these three, and we actually need the same thing twice. Oops. So we'll move that in here. And so now we basically have this, but doubled. So once again, we'll connect our x values to the top and the y values to the bottom. And we can also connect two new attributes or input values, I guess we could say. All right, shift right click, create another junction or a branch. Let's go in here and quickly name these just for clarity's sake. We'll call this cross size, and the second one we'll call cross thickness. Once again, I want the minimums on these just to be 0. It makes it manipulating the node a little bit easier. Close that with n. And now we have our inputs in. We have our two grid patterns, right? So we kind of want to repeat what we did earlier, where if we create a square around, for example, the junction, well, then we can create this sort of like plus sign, right? And by changing also a square here, we can kind of delete this corner and create a plus sign. So that's basically our goal here. So instead of up here maximum, we want it to be minimum again so that we get these plus signs forming. That's going to be our cross. If we now visualize what this looks like, it's going to be black for now because we didn't set any values. Put this to 0.1, I guess. We get these squares, right, like I was saying. So once again, we want to overlap this with our previous result. How do we do that? Well, we use the maximum because we want it to overlap the white instead of the black this time. So we'll put in the maximum, hook those up, and wow, would you look at that? You got some squares on your junction. So we're almost done now. How do we fix it so that instead of a square, we get this sort of plus sign, right? Let me switch back to my cursor. If you see, now we can change the cross size. You can also get some different effects here if you'd like. Like I said, this is really fun, and change it up how you'd like. This, once again, instead is a grid pattern, so nothing really happens, except if we add another one of these nodes here, connect the top value, excuse me, connect the top value, connect the bottom value, and set this to minimum. Well, we'll only get the black values this time, and we get nothing much, because I think our value is still around 0 here, right? 0.1. Yeah, so you see this kind of cross shape is forming. Let's set this to 0.2, and it's a little bit more obvious. If we change down the thickness, boom, you get what you want. So we basically have everything done now. We have all the effects that you'd like. So like I said, it's pretty much just repeating these three nodes over and over and combining them differently. But now everything's fully controllable. So if you'd like, you can change the scale, of course, and change your your overall grid thickness. I'm sure there's ways you can connect, for example, this grid thickness to your cross thickness with a few like adding. Like I can just take my grid thickness, math, add, for example, 0.1 instead to this value, or maybe 0.01. And that way you always have kind of a constant like thickness between or offset between your two values. But once again, these are just further developments you can kind of add going on. So from here, you can also just kind of leave and animate all these objects, right? So if you just use the keyframes, you can animate the scale, the rotation, pretty much everything about this, which is really fun. So now how do I apply this to the kind of light that I was doing before, right? Because that's when things really get interesting. For now, this is more, I don't know, a texture, a textile effect. It's not really anything interesting yet. So what we're going to do is we're going to copy all these nodes. For now, let's just kind of get rid of this texture. It'll help visualize the effect a bit better if it's black. Let's also go to the world and just set this to black. This is already in cycles. Set this to GPU. So now we add a light. This is when things might get a little tricky just because there's a few details that are often, let's say, looked over. Boom, we go into the object. Let's hit the use nodes button. We don't need this emission node. Hit Control V so you paste the previous nodes that we just made, and you can just connect it straight into your light output. If you go to your rendered view, you might say, whoa, good job, that's not working. Probably because your power is way too low. So if we turn this up to, I don't know, let's just say 100,000. Well, now doesn't seem to be outputting, let's say, the right colors or anything. First of all, this is probably because our spread's way too high, so it's not giving us the effect we want. If we set it to 0, well, now we can see we actually get the grid pattern. I like to leave this around maybe 1 or 2. We just get a little bit more fuzzy, like dynamic interactions between your surface and your light. But as you can see, if we move this around, it's pretty fun to see how it interacts with our plane. So if we go back here and we change our thickness, for example, to 0.02, get something that's a little bit thinner, a little bit more fun. And that's about it. So you set your spread down to 1 or 0 or 2, whichever you'd like. You set your power pretty high. And that's it. If you want to change the color, you can just add a little quick color ramp. You want to make sure this is set to black on this side, or else you get a extra light for no reason. And then you can set this to whatever color you'd like red, for example. And that's how you do this really fun effect. And then from here, like I said earlier, you can animate all these things. You can get a really fun dynamic effect, lighting effect that you can kind of throw into any scenes. This is a fun asset, cool scanning effect. And this is also repeatable, for example, if you want to do a scan in the X direction or the Y direction pretty easily. If we use the same setup where we use separate X, Y, and Z, I'll just show this quickly because it's pretty simple and can be used in tandem with this, for example, if you alternate between different light planes. We're also going to use, once again, the ping pong. Actually, we're going to need a math. We hit ping pong here, send the X value straight in, and another less than, oh, sorry, math first, less than, boom, boom, and then you just put this straight in. You change your value here. Well, instead of getting a grid, you can just get a line scan, right? So now you just change the position here, and you can scan the surface, whether you're using the X position, the Y position. So I kind of overcomplicated it with the grid, but it's basically a combination of these techniques here, which is what I wanted. So do with this what you'd like. I hope you enjoyed. Thank you.